So I'm still the same person, at least the last time I checked. Now, when you are doing kind of large-scale deployment of servers, and you want really to do cost optimization, you optimize by the cent, by the bolt, by anything. And those servers, in many cases, have just two connections, and that's it. Power from one side and network cable from the other side. That's it. And you have whole data center deployed based on that concept. Now, do you want to lose the access to your server? I guess not, right? But if you do, there are certain reasons that you want to guarantee that will not be part of your list of possibilities. So when you're doing that, and unfortunately, but that's reality, bad things happen, okay? Bad things could be anything from real malfunctioning, but user errors can lead you also to lose your server in a data center. Now, just think about, 100,000 server data center, and once in a while someone makes a mistake in configuration, and you're losing one of them. And losing a server, and I'm going to demonstrate that, can be very painful. Because when you do that, you may need to allow to ratify bad settings. If your configuration guys are sending settings which cannot be tolerated in a given system, it could be painful. Now, there are methods to do that. You can do some of the ratification through the BMC, through auto-configuration, not always. Because still the standardization did not reach a point in which everything is fully defined. So not each and every configuration correction may happen from the BMC today. Just think about what happens if someone configures too large bar size, or too many of them, or too many MSIXs beyond what the server can support. And in those cases, you may experience the last message that you will ever want to see in a data center when you have just one cable connected to your server and power, and no other mean to recover. So if this happens, you don't want to go physically to that server because that's painful. That's a big no in data center. So here comes what we are talking about now. Because if you see this message, which takes the last minute of your happy day, which recommends you remove the option card, go there and take it out. I don't know what to do with that card if you configure it too badly. And it happens. This is a real capture from a real system. There is a company which, in a different configuration, will provide you that one. I cannot tolerate that system. You have configured too much requirements into your card. And again, it's that single cable. You have no way to recover from that, right? So no, you can't. So what does it mean? We introduced today what we are calling Safe-Mode to NICs. Safe-Mode means that the card has the intelligence to identify that use case on its own and self-recover. Okay? So what does it mean? The card will allow you, as the IT operator of this data center, to recover remotely without having to access the server in order to fix your bad settings without having to take it out from the server. Sounds like magic. And finally, you don't have to do anything to put a card into safe mode. because you already lost your server, right? So if you lost your server, you cannot configure anything. We have the intelligence in our cards. How does it work? Practically, cards which are capable of operating in safe mode are self-detecting a case where the system fails to start up on their own. After a given threshold of pre-configured value that you can set on how many trials you let the system to try to start up, and not succeeding to do so, the card automatically goes into safe mode. In safe mode, what happens that the card enter a special mode, which we are calling safe mode, which the whole purpose of that mode is to let the IT guy recover the settings of the platform. So it is fully functional. You have network connectivity. You have your serial over LAN. You have the operating system comes up. And you also have clear notification that you are operating currently in safe mode. When you want, you can enable, you can disable that operating mode. Definitely, it's not something that we force you to do, but if you wish, you can turn it on or off and set that operating mode as non-volatile parameters. So if you wish, you can turn it off, of course. And you may want to configure the different threshold of how many trials the card needs to identify on the system, and you may want to do that in various ways. And there are different data centers using different methods to do the configuration. You may want to do it from the operating system, from HII menus, from the BMC. All of that is already supported. So how does it work? Device which enters safe mode practically shrinks its requirement from the system. Because we already talked that the root cause for causing that was misconfiguration, right? So if you guarantee that you shrink your system level requirements to the bare minimum, you are not the culprit anymore of causing the system not to start up. And by doing that, you allow really the OS to start. When you're operating in safe mode, you still expose to the user what was actually configured to your device, even though this is not the actual settings that you are requesting currently from the system. So for example, if you have set your bar size to 100 gig as an example, still we are using tiny bar size at that point in time, but we allow you to see that you have configured that 100 gig because we have special display for that. So if you are the user and you want to ratify, we tell you we are operating in safe mode. Now you can recover. That was your bad setting, and we'll show you how to fix it. So visibility is very important. You need to know that you are operating in safe mode. Yes?
So are you saying that when before the card is active, you configure the card, the system checks your configuration, and then it gives access to the memory space?
No. You're missing something here. When you power up a system, each and every card declares on a PCIe system, when you enumerate all these different cards, whatever it needs, how many physical functions, how many MSIXs, what's your bar size, and so on. And the system allocates resources. If you ask for more resources than the system can allocate for you, you may end up in those doom states. Now, our cards know exactly to identify those use cases, and when it happens, it shrinks its requirements from the system, indicating to you that it has done so by exposing that it is operating in safe mode, allowing you to ratify your settings. That's the whole idea, okay? So this is a capture that shows you that, again, a given device is already operating in safe mode. You know that it has happened, okay? If you'll open your HII menus, you'll see that marked in the corners, as you would expect. If you'll query that from the BMC, again, you'll have clear indication that you're operating in safe mode. The only thing that you need to do now is just to ratify the settings, the bad ones, that cause the whole thing to happen, and that's it. Reboot the system, and that's it. You wake up in fully functional. You don't have to take out the card out from the system. So there are 4 operating modes, of course. Like any new capability, sometimes you want to be able to control various operating modes of that new technology. So the first, of course, is if you don't want it, you can disable. That's trivial. You can enable it after a pre-configured number of bad reboots, be it 1, be it 100. I don't care. You have the span. And you can configure that number. And you can even set it only once. Now, you may think, why do I want to do that, right? It makes no sense. Why do I want to do it once? And the answer is simple. I'm doing now a change configuration. So most likely, if I'm doing now something wrong, I want to have that protection now. And if I'm afraid because of various reasons that my system may not come up reliably for other reasons in other occasions, then I want to protect myself now when I'm doing the configuration change. I activate that only once. If the system will come up, we'll identify that, and that's it. If the system will not come up properly, we'll enter safe mode. And of course, you can always activate that. That's obvious for us. Now, defaults, as I said, can be fully configured. You can enable, you can disable that using non-volatile parameter in our devices. And of course, the number of bad reboots that you are looking after is fully configurable. So we have that solution, but people may ask, okay, what can we do for the wide industry? Because this is patented technology of Mellanox, which is already available. If we have a method, the whole thing started because there is no method today to ratify bad settings from a standard interface, be it a BMC or whatever. So maybe it's time to call for definition of allowing a BMC, because the BMC not necessarily may be able to interrogate the root cause, just to force devices to operate in factory default. If we'll have that, then practically we can gain similar benefit, but the bad things behind forcing devices to operate in factory default definitely is the fact that you'll have to reconfigure them, okay? So if you have our technology, you don't have to reconfigure everything from scratch, because we minimize the safe mode to things that we know that may cause you, but not necessarily raising your boot settings, iSCSI, whatever. If there is no rule for that, and we go to factory default in a standard way, still it can allow you to recover in a standard way if such defined. Thank you.